Hi, this is Sarla, Assistant Professor, Department of Mathematics, Dr. Enjoy Educational and Research Institute. So my topic is eigenvalue and eigenvector. This is from the chapter Matrices. So go on to the topic. So before go to the topic, let's recall the previous things. Characteristic equation. So our characteristic equation formula is determinant A minus lambda I is equal to 0. By using the 2 by 2 matrix, we have the characteristic equation is lambda square minus S1 lambda plus S2 is equal to 0. S1 is nothing but the sum of the main diagonal elements and S2 is equal to determinant A. For the 3 by 3 matrices, we have the lambda cube minus S1 lambda square plus S2 lambda minus S3 is equal to 0. So S1 is here main diagonal element, sum of the main diagonal elements, and S2 is sum of the minor of the main diagonal elements, and S3 is determinant A. So from the characteristic equation only we are finding the eigenvalues. So eigenvalues definition is let A be a square matrix. The characteristic equation of A is determinant A minus lambda is equal to 0. The roots of the characteristic equation are called eigenvalues of A. So roots is nothing but the eigenvalues. So we are going to find out the roots from the given matrices. So A is equal to 1 minus 1. 1 is the example for the 2 by 2 matrix. So characteristic equation of A for the 2 by 2 matrix is lambda square minus S1 lambda plus S2 is equal to 0. So S1 is nothing but the main diagonal element. So 1 plus 1 we are getting 2, and S2 is a determinant A value. So 1 1 minus 1 1. So this is 1 minus of minus plus 1 is 2. So from the S1 and S2 we are substituting the values in the equation. Lambda square minus 2 lambda plus 2 is equal to 0. So it can't be factorized. We are going to apply the quadratic equation. So our quadratic equation is minus b plus or minus root of b square minus 4ac by 2a. So our a value is here 1 and b value is minus 2 and c value is 2. So from this we are getting this one. So 2 plus or minus root of 4 minus 8 by 2. So 4 minus 8 is minus 4. Minus 4 is the complex number. So we are taking the minus 4 root is 2i. So from taking a 2 common in this one in the numerator, we are cancelling the 2 in the numerator and denominator. Finally you get the lambda value is 1 plus or minus I. So therefore here you are getting the two roots. One is a 1 plus I and another one is a 1 minus I. So this is the example for the 2 by 2 matrix. Next we are move on to the 3 by 3 matrices. Find the eigenvalues of the given 3 by 3 matrix. So for the characteristic equation of 3 by 3 matrix is lambda cube minus S1 lambda square plus S2 lambda minus S3 is equal to 0. S1 is nothing but the main diagonal element. So sum of the main diagonal element is 1, 3, 3 is equal to 7. So the next one is we are taking the sum of the minor of the main diagonal element. So sum of the minor of the main diagonal element is we are just eliminating the main diagonal elements rows and columns. So if suppose our first element is 1 means we are eliminating this column and this row means remaining thing is going to be a minor of the particular one. So 3 minus 1 minus 1 3. And next we are move on to the second main diagonal element is 3. So here I am eliminating this column and this row. So we are getting 1 0 0 3. And next we are going to eliminate the last main diagonal element is 3. So this column and this row. So wherever you have the element, that particular row and column you have to eliminate. So 1 0 0 3. If you solving this one, you're getting the value 14. And next S3 is equal to determinant A. So determinant A is you know very well. So you just find out the determinant A value, that is the 8. So finally substituting all the values S1, S2, S3 in the equation here. So S1 become a 7 and S2 become a 14 and S3 is a 8. So the characteristic equation become lambda cube minus 7 lambda square plus 14 lambda minus 8 is equal to 0. From this, we are going to find out the roots. Just here you have that polynomial degree is 3. So that's why we are first substituting and finding the value for the first root. Lambda is equal to 1 means you're getting a 0. So lambda is equal to 1 is the one of the root. From this, we are going to find out by the synthetic division. So our equation is lambda cube minus 7 lambda square plus 14 lambda minus 8. So just take the coefficients of all the things 1, minus 4, 14 and minus 8. Then doing by using the 1 we are solving. So 1 here this is synthetic division is so just solving this one you get the values of 1 minus 6 8 0. So this in this one we are eliminating the last value 0. So now you're getting the degree lambda square minus 6 lambda plus 8 is equal to 0. So in this equation our value is or if you factorize the lambda square minus 6 lambda plus 8 is equal to 0 means you're getting 2 and 4 and already you have the lambda value is 1. So finally lambda is equal to 1 2 4. So this is the 3 by 3 matrix, therefore you're getting the eigenvalues, that is the roots are 3. So from this you know how to find out the values for the 3 by 3 matrix and 2 by 2 matrix. So just try these things as a sums for the 2 by 2 matrix and 3 by 3 matrix. So if you done this way you can find out the values. Okay. Thank you, students.